We're given 1 plus x to the n is equal to this sum. In part A, we want to find the ratio of the terms, the sum of the ratios. We want to show that it's equal to n over 2 times n plus 1. One thing to note is that this is part of the binomial theorem. So in general, 1 plus x to the n is n choose 0, 1 to the n, x to the 0, n choose 1, 1 to the n minus 1, x to the first, all the way up to the nth, so it'll be n choose n, 1 to the 0, x to the n. So these combinations are the a0, a1, and an, etc. So when I'm looking at a1, I want to think about it in terms of a combination. So a1, well, that's just n choose 1. Okay, so notice that the bottom numbers are the same. And the top is always going to be n. Okay, so that's n choose 1 over n choose 0. That's 2. N choose 2 over n choose 1. N choose 3 over n choose 2. And then this is the nth term, so it'll be n choose n over n choose n minus 1. So on the top here, n choose 1 is just n choose 0 is 1. Okay, this one is a little tricky. Well, n choose 1 is n. We have 2. And this is n factorial over 2 factorial times n minus 2. Okay, and this will be n factorial over 3 factorial times n minus 3 factorial over n factorial, 2 factorial, n minus 2 factorial, all the way up to the end here, which, let's see, n choose n is 1, so that's n, and then n choose n minus 1, well, that's just n. Okay, so let's see what happens. We have n here. The 2's are going to cancel. I'm left with n factorial over, I have n in the denominator with n minus 2 factorial. Okay, this is tricky. Let's see, the n factorials are going to cancel. The 2 factorial, the n minus 2 factorial is going to come up at the top. So I have 3 times 2 factorial times n minus 2 factorial over 3 factorial and times n minus 3 factorial all the way up to 1. Okay, so this is n. So the n's are going to cancel, and I have n minus 1 factorial, which that's going to cancel, and you're going to be left with the n minus 2, so that you'll be left with n minus 1. 3 times 2 factorial is 3 factorial. The n minus 3 factorial is going to cancel, so you're going to be left with n minus 2. And if you continue this further, we'll go all the way up to 1. And notice, this is the exact formula for n times n plus 1 over 2. Okay. So part A is proven. Now let's review part 2. Okay, so we want this sum to equal 3 to the n. So this is a very easy proof, because we're going to use the given. We're going to use the top here. If 1 plus x to the n is equal to that, well, I'm going to substitute x equals 2. So then it's 1 plus 2 to the n. Okay, so that's a0, 2a1, 4a2, you know, all the way up to, let's see, 2 to the n times an. Okay. So 1 plus 2 to the n is just 3 to the n. So we have this. And that's proven. Okay, so now we've proven part B as well.